This is an example of a hypothesis test for population mean when sigma is known. A job placement director claims that the mean starting salary for nurses is $34,000. A random sample of 10 nurses' salaries has a mean of $33,450. Assume the population of nurses' salaries is normally distributed and the population standard deviation is 4,000. Is there enough evidence to reject the director's claim at alpha equal 0.10? This is a z-test because we're told that the population is normally distributed and the standard deviation, sigma, is known. Writing the claim as a mathematical statement, the claim is that the mean salary is 34,000, so that's mu equal to 34,000. Because it contains the case of equality, it's the null. That makes the alternative not equal to 34,000. To find the p-value, and in this video I'm using the p-value method, we need the standardized test statistic, which is x bar minus mu over sigma over the square root of n, what we observe minus what is hypothesized or claimed, divided by the standard error of the mean, and it is a z-score. The sample mean from the problem was 33,450, sigma was 4,000, and our sample size was 10. Inputting that information into the problem, I get a z-score of negative 0.435. I expected this to be negative because what we observed, the sample mean, is less than the hypothesized mean. Now the p-value is the probability of getting a test statistic at least as extreme as the one obtained by the sample. And because we have a two-tailed test, because we have not equals in the alternative, we're going to have two areas of rejection, and we're going to need to divide alpha in half. So alpha is given as 0.01, and our level of significance is an area, or a probability. So that means I'm going to have 0.05 amount of area in each tail of rejection, because 0.10 divided by 2 is 0.05. So I need to find the area that corresponds to our standardized test statistic. The test statistic is reasonably close to 0, so I know just by looking at it, my decision will be to fail to reject the null. But to know for sure, let's find the p-value. The p-value is going to be double the area going further to the left of the standardized test statistic, and it's actually going to be half of the p-value. Because we divided alpha in half, this area here represents half of the p-value. So after we find this area corresponding to our test statistic, then we'll go ahead and double it to get it back in terms of comparison to alpha. So in probability notation, this is going to be the probability we get a test statistic less than negative 0.435. To do that, we can use either the standard normal table in your textbook or the normal CDF function in the calculator. Going to my distribution menu, selecting option 2. My lower bound is a very small number, so I can leave it as negative 1 times 10 to the 99th power. My upper bound is 0.435. And entering, I get an area of 0.332. But remember, this is only half of the p-value. So to double that, I'll get 0.664. So 2 times the p-value. I'm sorry. 2 times the probability z is less than negative 0.435. We get 0.664. Now when your p-value is greater than greater than or equal to your level of significance, you know the decision is to fail to reject the null. So going back to our null and our alternative, we're failing to reject the null. So the correct way to answer the question, is there enough evidence to reject the director's claim? There is insufficient evidence, or there is not enough evidence to reject the claim that the mean nursing salary is $34,000. To get the standardized test statistic and p-value directly, we can go to the z-test, pressing stat, right arrow over to tests, select z-test. We have our summary statistics. The null statement is 34,000. The assumed population standard deviation is 4,000. The sample mean was 33,450. Sample size was 10. And you need to make sure you select the correct alternative, otherwise you won't get the right p-value. And we'll see from the output the standardized test statistic is about the same. It is the same when we round to 3 decimal places. And the p-value, rounding to 3 decimal places, is also the same.